Okay, so here we have the float program that we had from just the last video, and I have a few slides to talk to you guys about regarding basically it's a review of what we've been doing because there's some things that uh, we need to know. So what have we been doing? So when we go ahead and click compile or compile and run, you guys need to know that there is a .exe, and that's just an executable file that's ran by Microsoft Windows, and it basically combines all of our C++ code and files, and it's understandable by the operating system. In our case, it's Windows 7. It could be XP, Vista, but yeah. Another thing to understand is the exe will never get compiled if you have compiler errors. So here's an example where there's a plus right here, and anything that doesn't end with a semicolon won't work, basically. Or if you have stuff in between that's not supposed to belong. So now if we go ahead and just click build, here it works perfectly. And to show you guys that there is an exe, if you're using code blocks like I am, go ahead, go to where you have everything saved. So for me, it's username code, and I've done this before, so it's finished, and your exe is saved under bin debug float. So you could just run that like normal, and try not to quit from here. Always try to finish your program and end it. So, and also don't type illegal characters because that would return something other than 0 back to, if you're debugging, it'll it'll come up here that uh, the process ended unexpectedly. So let's go ahead and go to the next slide. And I talked about the compiler just a second ago, but there's a few things we need to know. It's basically, it turns all our C++ files and all the code we have written into a exe for us. In our case, the compiler is mingw. It's a GNU CGG, basically open source compiler for Microsoft Windows. And back in the day, people used to write their own compilers, and even before that, before the real C++ language or any sort of computer language, we'd have to program in uh, directly to computer memory using binary. If you go back far enough to something like when computers have had dip switches on them, so like in IMSI 8080, you'd have the switches on the front, and you'd basically type each binary code in, and then you set it to memory, and then you type another line, and then you do the same thing, and then in between those two, uh, after binary and before compilers, you just type a command directly into the computer and program it that way. So just a little bit of background info. Now, you've probably noticed that at the beginning we used to use system pause over here, but now we use input.get, and this is evil in the sense that it only works on Windows. It's more resource intensive. It actually runs, I believe, 2 processes, and it defeats security because you have no idea. This is a Windows only call. So if there's something wrong with the computer, has a virus, calling this, the operating system it could just make it worse. So you don't know if the system's been compromised. But the pro is that it's easy to use. Just write system pause. But we're transitioning to input.get, as you've noticed, and it waits for us to type something in and hit wait, and it waits until we hit enter or return, but it doesn't actually tell us to hit enter. It just waits for a keystroke. While this would say press any key or press enter to end the program. This won't. It'll just say nothing. So your program will finish and it's just going to wait there. So you're going to have to actually click enter, hit enter, or even just type a letter and then enter. Um, in the future we can make a prompt that's specifically asks for enter to be hit and click enter to end the program. So uh, this is a lot better than using system pause, just so you guys know. Now let's go to the next slide. Obviously, you've noticed under your sources file you have something called main.cpp. CPP stands for C++, and it's a source file. It's where everything is going to be typed in, and you can only have multiple source files, except they won't all be named main. So only the C++ files are actually compiled. Everything else aren't technically compiled. Some of them may be pre-compiled, but so for example, it's like include statements, or not statements, sorry, just include. So we have you can use include test.h, and test.h is we can add another file here that will reference our main C++ source file. We'll know to go to the main.h file to look up stuff like maybe a function or anything else. Next we have include IOStream. This is usually pre-compiled in some cases, sometimes not. This is basically telling the program to IOStream is what causes the stuff we type in to get printed on the screen, and not, like, for example, printer or saved to a file. And just so you know, if it's in quotes, it's a local file within our project, while I'll just call them alligator brackets are used when the compiler already knows where it's at. So the compiler already knows where IOStream's at. You just say IOStream, compiler will deal with it. It knows where it's at. And a little bit more about include. Their real name is actually preprocessor directives. Some of the time, these could be pre-compiled, so it doesn't need to be recompiled, because it usually takes a lot of time to compile, especially if you have a enormous amount of preprocessor directives, like say you're making a video game or something else. And a lot of these are needed to actually allow statements in our C++ file to work. So if I just took out IOStream, like it would not know where to output choose a regular number, or output end line. So it would just say, okay, I'm outputting it, but where? It won't know. Like I said, there's one for outputting to a file, there's one for outputting to a printer, and of course IOStream is to the screen, like I said. Next we have, you've probably noticed using namespace. This actually stands for standard, and it's a standard library. It's basically, in C++ we have libraries of functions and commands that have already been sort of dealt with by other people. They built them, and so we can actually download libraries. Like, say we could use a library for drawing a square on the screen, or I don't know, math libraries for calculating. Let's say you need to find the answer to an equation, right? And because float only holds about 7 digits, you need to have like 50 digits of accuracy, so you have to download a new library and use that. Next we have functions. You probably didn't know this until now, but functions end with braces and ends with braces, and as you've probably seen, there are 2 braces right here. So actually main is a function. We'll make more functions in the future. One of the ones that we'll get into is void. Void. So we can name it void. I don't know. This is a function. We'll do that, and then we'll add our braces. And there you go. You just created a function. Um, so they have names. You can name it anything you want. You're gonna declare the type first. So int is an integer type, so it's gonna expect numbers. Um, again, they have names. This you could practically name it whatever, but for the purposes of keeping our program, I want to say compliant, but it's just sort of something done out of, it's still there. I mean, it'll run even if we don't name it main, but main is just something that's been used since C++ was created, and uh, it's just basically there sort of like for tradition and to keep backwards compatibility in case you're running on some system that doesn't allow the function to be named anything other than main. And you have to have at least one function that does something. Uh, and the purpose of functions is usually to solve the calculation, check equality, see if something's true or false, and then take that answer and put it back into a main function. So that'll actually be maybe the next episode or 2 episodes from now. We'll talk about functions and how to create them. Next is our semicolons. Just so you know, everything that is a statement in C++ has to end with a semicolon. So as you can see here, float A, float B, that's a statement. Outputs, inputs are statements. Return is a statement. Functions and preprocessor directives are not statements, which is why you don't see semicolons over there. So there are other things that aren't statements in C++. There aren't a lot, so most things will have a semicolon to end the statement. So if you don't have a semicolon, it won't compile. So say I take my input to A, you're gonna see it's gonna say, oh, there's a missing, bracket or semicolon before A. So yeah, and I think that's it. Oh no, I lied. Oh yeah, with our input and output statements, these inputs are called stream insertion operators because you're inserting something from the keyboard or from whatever to a variable, and these are called stream. No, wait, I messed that up. Sorry. These are stream insertion operators because you're inserting from the computer to the user. They're named backwards, so stream extraction operators are you're extracting something from the keyboard to a variable. So you're taking it from the keyboard, moving it that way, or you're taking it from the computer and moving it to the screen. So this is a insertion operator. This is a stream extraction operator. I have no real examples right here, but here, we'll do the \n. It's known as a return carriage, as from a typewriter, when things should be called typing and not keyboarding. But yeah, it can also be referenced as an escape character. Some people like to call it that, but it's not technically right. So just in case you hear someone say escape character, why. Don't call it that because the escape character is actually the escape key on your keyboard. Next, we have different types of stuff that we can output. For now, some quotes will always be used for text. Math calculations do not require quotes and should not use quotes, because otherwise, if you do use quotes, it'll make it a text output rather than actually calculating something. Next, we have endl. I went over this in one of the videos, but endl basically means end line, and endl is a statement or a command, so it's not going to be in quotes, even though it seems like it should. And I don't know if you guys have noticed, but we can actually do stuff like here. We can actually, this doesn't need to go down. We can actually go ahead and have multiple output statements with one output. So we could do something like that. We're like, this is the mean, and then it's going to output this. Should probably add a space. So I go ahead and build and run that. You guys will see that it's choose a regular number of 56.5, 44.3, 98.2. You're gonna see that the sum of ratios is 69.33. So, and the mean is 69.33 again. Whereas here I started a new line by actually typing another output and then typing end line. While here I could just, if you want to output multiple things without having to declare so many, or just to use so many output statements, you could just add multiple insertion operators. So another thing that we need to be aware of is, where is our output saved? I talked about this in the other thing. It's stored in system RAM or system memory, and permanent storage happens on the hard drive. We also declared variables, so it's just like in math class, except we can actually store text also using variables. You can just store strings of text, or strings of text basically mean like an entire sentence, while we can have something called char, which is a character, and as you probably imagined, a character is any one single letter or symbol. And in C++, this is very strict. You can't technically assign a letter to a number, although you can, because if you've ever heard of ASCII, it's basically like the number codes for letters. So like a letter, like let's say F, will have a certain number code. So if you actually do assign a letter to a number, it's just going to output the number code instead of the actual letter. But we try to avoid that. Just in case you do want to know the letter, just like look it up on a chart. And then a little bit about variables is that we declare type, then space, then actual variables. So declare type, and by space I mean we could have written like, this is a bad example since it's float, but we could have written something like signed short int, and that's what I mean by that. And then the actual variable, it could be a, it could be pizza, it could be, I don't know, cat. So yeah, I'm just gonna do my float back in. We have a sign operator, which is equals to symbol. Do not say it is equals to something. It's actually a is assigned the value 5, so that's a proper way to say it. And I think that's about it for now. Yep, that's the end of the PowerPoint slide. So basically, as long as you were able to get understand what we just talked about, you should be fine for now. Next episode's probably gonna be I have a to-do list, so I got done with the review PowerPoint. Next we're gonna talk about if statements, then logical operators. We might do constant variables right after that, or make it part of the same thing. So yeah, whatever I release next is whatever is on the list. So that concludes this portion of the review. Thanks for watching. Please leave a comment down below if you have any suggestions or have any questions, or just want to, say thank you. And please like and subscribe if you enjoy the content.